Good morning, ladies and gentlemen.
Morning, sir. How are you?
Morning.
Morning.
Uh, Good morning. Yes. Good morning. Good morning. Good morning. Good morning, ladies and gentlemen. Good morning, ladies and gentlemen. Where is my yam? Good morning, ladies and gentlemen.
Morning, sir. Morning, sir.
Yeah. Good morning.
Morning.
Is it true that today you are writing the test?
Yes,
I
sir.
mean, those who are doing mathematics.
The writing mathematics, sir.
When? At what time?
I ask someone here at Math Building.
Oh, then I have few announcements. Let me make an announcement. The first announcement is that after this class, make sure you come and collect your scripts. After this class, make sure that you come and collect your scripts. That is the first announcement. The second one, I'm just waiting for
Sir,
those who are writing mathematics,
at one, sir. The writing
or
at
they're writing at 1. It means at 3 they will be done.
yeah, I think so.
Oh, okay. Then tutorial today is at 3 o'clock. Let me just explain how I do my tutorials. I send you tutorial questions before so that you can attempt them. And during the tutorial sessions, I will be there, but you'll be the ones that interacting with one another if possible. If you're having any problem, then it's when you can raise the hand and say where you have a problem. I don't like writing, but that means I'll be giving you some hints in a tutorial how to go about. And the other one is that on Friday, the third announcement, on Friday, 7:30, you will be with Mr. Maluleke for feedback for the test. He will be giving you the feedback on the test, how you went about writing the test. And on the same day, on Friday, also he'll be addressing the issue of the special test for those who did not write the special test. The last announcement is that next week, Friday, 7:30 class, you'll be writing the quiz. The quiz will be on chapter 3. The quiz will be on chapter 3. Next week, Friday, 7:30, the 2nd of September, you'll be writing the quiz. Those are announcements. Any question? Any question, ladies and gentlemen? Remind me 10 minutes before the end of the lecture. Remind me so that I can repeat this announcement, because I can see that others are still coming in. Remind me so that I can.
Will he also post the marks of test 1 on Blackboard?
The marks?
Yeah.
I don't know, because you must come and collect the script first. Then if you feel that there is a inquiry that you want to do, then you can inquire before you publish the marks. I don't think we will publish the marks this week. Yeah. Simanga.
Sir.
Simanga. Yes.
Sir.
I'm listening.
Oh, sorry, sir. It means that I raised the hand by mistake.
Okay, no, it's fine. Any question on the announcements? I will repeat them 10 minutes before the end of the lecture. Now, as we said yesterday, okay, are we collecting? Okay, you're collecting Mr. Maluleka's office. you collect in Mr. Maluleka's office the test. Okay, thank you very much. Today, as we said yesterday, we did theory on interaction, and we said today we will deal with the example. This is an example that we said we are going to do today. Now, you remember, and we have to find this, the ANOVA table, before we can test for interaction. We have to construct the ANOVA we have to do the ANOVA. I was still speaking, but I think right now I have something on screen. Do you see it? Ladies and gentlemen, do you see it? Remember, I cannot see you because some, okay, but you see something. Let me do this, minimize everything, then let me try to do this. Yes, then so that I can see both. Now, you remember yesterday we constructed the ANOVA. We did the theory on the ANOVA, how to construct the ANOVA, so that we can test the interaction. We always first test the hypothesis about the block by treatment interaction. Whenever you do the test, you start by doing what? The interaction. I will tell you, if you do the interaction, then what comes next is under the main effects. If we fail to reject the null hypothesis about the interaction effects, we test the main effects, which are treatment or block effects, under both models. That is the fixed random effects model, fixed and the random effects models. Now, what do we mean? We mean that if we fail to reject the null hypothesis of the interaction, then we test the main effects. What are the main effects? We test the fixed, where we test the blocks and the treatment. And we also do the random effects. But if we reject the null hypothesis, there's no need to do the main effects. That is very clear. But I wanted to do this. Now, we start by what? By doing, what we call the interaction, testing the interaction. It means all interactions is zero. All the interaction is at least one interaction is not equals to zero, or one interaction is different. Now, let's start. The first thing that we must do is to construct the ANOVA table. Today, what we are going to do today for this first period is to construct the ANOVA table. For this period, we are going to construct the ANOVA table. Then the second period, then we are going to test this one. We are going to test the interaction effect. If we get that, if we fail to reject the null hypothesis, then we will do both models, which is the fixed, where we test the treatment means and also the block means, and also the variance under the random effects model. Is it very clear, ladies and gentlemen, what we are going to do first period?
Yes, sir.
Okay. Now let's start. Let's start. What do we do first? Is the ANOVA table. Now that means we must have the treatment, the blocks, the interaction, the error, and the total. We must have the degrees of freedom. We must have the SS, the sum of squares, the mean sum of squares, and the F ratio. This is what we are going to construct. Now, these are the formulas. These are the formulas. These are the formulas. We can start with the total. We can start with the total, then go to the treatment and the SSB. Then we do the we do the model. This one. I hope I have. Okay. Let me do this. Let me do this. There is one slide here. I think it's not there. The model where we the model. I'm just checking it. This is the formula for the model, but you don't use this one. Let me put another that model. That model. That model, so that you may not die. The model. I want to show you the formula. I know that you are using those formulas as I had. The formulas. Yes, this is the model that I was talking about. Let me do this. This is the SS model. I know you know these formulas. Now, I want us to do the ANOVA table. Can we start with the ANOVA table? Let's start with the SSTS. Let me do this. Now, can you take a picture for this? Can you take a picture for this example? Let me know when you are done. Take a picture. We are going to calculate this. To estimate the various components of variability in the infiltration process, the percent of material lost in the mother liquor was measured for 8 experimental units, 2 runs on each condition. 2 filters and 2 operators were selected at random to use in the experiment, resulting in the following measures. Do the data suggest the presence of operator by filter interaction? What do they say? Do you think that there is a presence of interaction? Do you think there is a presence of interaction? Now, are you done taking a picture? Ladies and gentlemen, are you done taking a picture? Okay. Now, since you are done, now let's calculate, because remember what we want to do right now, this first session, we want to construct the ANOVA table. Now, we start with the SS total. Now, can we calculate the SS total? 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 Let's calculate the SS total. Let's calculate the SS total. Now, what we want to find is the SS total, where the SS total is given by the T, the B, and the R, where R represent the replication. How many things are repeated in that block? Then this is K. Now we have this squared minus 1 over TBR. Whether you say BT, it does not matter. Dot, sorry, dot, squared. Now we said this is the total. We said this is the total. Now, since you are calculating, to give others some background, we said filters are treatment. Yesterday. Filters are treatment. Operator, filter is treatment. Filter is treatment. Then operator is block. That means going down is block. That means horizontal is treatment. Now, ladies and gentlemen, are you with me? Ladies and gentlemen, are you with me? Okay. Now, I want you to give me the following. The Y dot, the total. What is Y dot? How much is Y dot? Okay, I'll come to you. Let me do this. Before some will say, hey, can you? This is 19.5. Yes. 22.2. 23.4. 30.1. 24.2. Now, what we want, total, what will be the Y I dot? This will be 1. Sorry. As some are doing that, this is 1 dot. Y dot. Y2 dot. This will be blocks. Y dot. Y. Then this will be Y dot. dot. Now, ladies and gentlemen, what will be the y1 dot dot? What will be y2 dot dot? 62. What will be y dot 1 dot? What will be dot 2 dot? Then what will be dot dot dot? Okay, 91.4. Okay. Ladies and gentlemen, do you agree with the do you agree with Ntauleko? I hope I pronounce it well. Ntauleko. Nta? Nta? Do you agree with Nta? Okay, yes, yes, yes. Do you agree with those numbers? That y1 dot dot is 62, y2 dot dot is 91.4? Okay, okay. Then, ladies and gentlemen, anyone who find it difficult to find that 62? Now, let me ask, what does this represent? Is it blocks or treatment? This one, the one that is in the box. Is it treatment or blocks?
I think treatment, sir.
Yes, yes, it's treatment. Who's talking? Bless you.
Bunda.
Maboda, bless you. Yes, it's treatment. Now, let's find the total for blocks. Let's find total for blocks. Let's find total for blocks. Let's find total for blocks. Ladies and gentlemen, blocks, not blocks, this ones. Can we find the total for blocks? Do you agree with Neo? Do you agree with Neo? They said this is 53.5. What about y dot 2 dot? Okay, I was told 99.9. Okay, do you all know how to find the blocks, the total for the blocks? Any question, ladies and gentlemen, before we proceed to y dot dot dot? Please, sir, please explain the range of these observations. Ezekiel, I don't understand your question. You are saying, how did we arrange? If the way I'm thinking, you are saying the way, how did we know that this is filter? How did we know that this is operator? Oh, yesterday, were you there yesterday? Yesterday, we said when we were doing that example, we went back to, we were here, and we said, do the data suggest the presence of operator by filter interaction? Okay, then we went back to theory. Here we said the presence of block by treatment interaction. Do you see? Block by treatment. Now, when you go even here, it's here, to account for variation in the responses that is due to the block by treatment interaction. Now, when you look at this question, now, what do you think is block here? Do the data suggest the presence of operator by filter interaction? Ladies and gentlemen, can we help another fellow student? Yeah, block by treatment. Yeah, thank you, Karabo. Block by treatment. Now, look at this statement and look at what Karabo said. Block by what? By treatment. Do you see it? Where is Ezekiel? Prophet Ezekiel? Oh, you understand? Yes, yes, yeah. Oh, yeah, yeah. Karabo is answering you. Thank you very much, Karabo. Thank you. Thank you very much. You are an answer. You've given him an answer. Answer, answer. Karabo means answer. Yes. Oh, the observations. Okay, let me explain the observations. Now, we have two observations, which is under 1 and 1. We have 7.6 and 8.8. 8.8. Now, why are we having those two? Now, we go back. Now, look at this. That we have what we call replication. That means we are repeating. Are they, okay, how they are arranged? Okay, this is just, look at this this table. This table. It says we have the value, which is the observation 1, observation 2, until the last observation under block. You remember when we were doing the you, Ezekiel, were you there yesterday? Because I explained this, that under this you were having treatment, you were doing repetition using the treatment. Now under this is under block. We are doing everything under block. Look at this. These are the observations. These are the observations under block. Do you see? There are how many? 1, 2 until the R. Ezekiel. Then you have to find the total. This is the total of this block and the mean of this block. Ezekiel. That means here we are having how many? Look at this. This is 1, 2 until the R. Repetition. That means it's repetition, replication, repetition. How many are replicated? Now, when you go to our example, now there are how many? How many are repeated? Or how many are they? There are 2, yes. That means we did replication 2. You're going to see it when you do it in Excel. It will ask you how many replications. Then because here there are only 2, then you will say 2. Do you see it, Ezekiel? Do you understand, Ezekiel? You managed to see it? Do you understand? Oh, thank you very much. Now, I believe some of you, you are too far. You are far. Maybe you are at, you have managed to construct the ANOVA. But let's do it together. What will be y dot dot dot? Y triple dot 153.4. Remember again, let me explain so that others may not ask me. There are 3 dots because we are having the I for treatment, we are having the K, the J for blocks, and we are having the K for interaction or the replication. I for treatment, J for blocks, and K for replication or interaction. Yes, I hope I've explained why they are triple dots. Now, because we are done, now let's go to, let's calculate the SS total, where the SS total is the T, the B for blocks, the K for the the K for the interaction, the R, let's say R, because we are using R, the interaction. Then this is will be Yij K minus 1 over TBR dot. Then what will be the TBR? How many treatments do we have, ladies and gentlemen? How many treatments do we have? How many blocks do we have? How many replication do we have? When you are saying 2, 2, 2, I don't understand. There are 3 questions: the treatment, the block, and the replication. Can you just give me those answers? Okay, this is, thank you. This is 2. This is 2. This is 2. Do you understand, ladies and gentlemen, why we said treatment 2, block 2, and replication 2? Okay.
Yes.
Then, okay, thank you very much. Who's talking now? I don't see you, but when you are talking, I can hear. Now, what will be the answer for TBR? The answer TBR. What will be the answer? It will be 8. Thank you very much. That means your N is equals to 8. The total N is equals to 8. Then what will be the answer for SS total? What will be the answer for SS total? Yeah, you can talk because I don't see.
Hello, sir. How is it 8? I'm confused.
Oh, 8. Remember, we are having T times B times R. Can you multiply?
Oh, okay, no problem. Thank you.
Oh, thank you very much. I've got 4 point, sorry. I wrote 8. I don't know where I got 8. SS total 5.1815. Do you all get this answer?
Yes, sir.
Samanga. What are those numbers? Samang. Oh, you have calculated and calculated and calculated. Okay. Murunga, you are saying we are fast. Murunga. Okay, I will just peg here a little bit to explain the 8. How did we get the 8? While Murunga is still calculating. The 8 is T because we said the treatment, there are 2 treatments. This is 1 and 2. And there are 2 blocks. It's 1 and 2. That means it's 2 treatment. And we are having blocks. There are how many? There are 2. And replication, that means R. How many observations are there in block 1, in each and every block? That means we are saying there are 2. 2 here, 2 here, 2 here, 2 here. There are 2 treatment, 2 blocks, and 2 R. Then is 2 is TBR. That means 2 times 2 times 2, which is 8.
Sir,
Yes.
is the answer 415.94 or 0.815?
Yeah, I just want to ask. Let me explain this. I will come to it because Kavelo is, Murua is still calculating. Now, this is the total. Is the answer correct? How do you put
Yes,
3
sir.
summations on a calculator? How do you put 3? Is your calculator having summations? You are having advanced calculator. Let me see mine. Mine does not have summations. Smang is 415.815 total. Is the total correct?
Sir, according to me, no, sir.
Or is no?
Because I put the data on the calculator, then I found the summation of the square for the 3, which is 3358.1484. Then I subtracted by
Wait a bit. Let me write it. Let me write what you are saying. You are saying the sum of 1, 3. You are saying is how much?
It's 3358.1484.
335.
8. 1484.
14.
84.
84. This minus 8. Let's do this. Minus 1 over 8. This is squared. This is squared. 1534 or squared. How much do you get?
415.93635.
Or do you all get that? Let's say this is 3358.1484. How much is that? How much is this? How much is that? How much?
Sir, it's 2,942.21205.
Two numbers.
2,942.
That triple summation of YIJK spread is wrong, sir.
Wait a bit, guys. I'm able to hear myself. 294.
Can you hear me now?
0.21205.
2105. When you minus this number, how much do you get? This one and this one.
It's 415, sir, 0.93635.
Oh, yeah, that means it's correct. Yes, it's correct. This one is correct.
Sir,
Can you mute your mic? Thank you. Oh, yeah. Then, let's continue. Do you all see it, ladies and gentlemen? Do you all see it?
Yes, sir.
Okay, let's continue then. Let's find the SS treatment, where this treatment is filter. SS filter. Can we find SS filter? where SS filter is 1 over BR, the sum of T, where R this dot squared minus squared. Now, you must tell me if I'm fast, because some of you, I think you are done with ANOVA. SS treatment, not blocks. Okay, 108.045 I was told. Do you agree with Stephen, Neo, and Karabo? Yes, yes. Where is that lady who said we are fast? Okay. Now, do you all understand how we got this one? Oh, Muruma, yes, I was looking for you. Did you get this, Muruma? Yeah, then give me the SSB, which is the blocks where this is operator. Oh, yeah, Muruma, you must give me the numbers. That will be 1 over TR, sum of this is B, that will be I dot J dot squared minus squared. I got 269.12. Do you all get it? I see. Okay. Muruma, are you still there? You must let me know if I'm fast. You must let me know if I'm fast. Okay, let's continue. Now let's go to the next one. Oh, Vero, you are saying you did not get the what? There is Ezekiel says he's getting 261.118. 26. Ezekiel, please, what I can encourage you is that just calculate them. Okay. Then they have managed to give you some hint. Oh, now you see, they're giving you answers. Okay. Vero, are you winning? Vero? Vero, are you winning? Vero? Okay, what is the problem? You can't calculate what? Now, let's do this. Okay, let me cancel this. Vero, I'm using the operator to give you a hint. SST value. Ooh, let's do this. Now, this is 1 over, the B is 2, the replication is 2. Then this one, the I, the Y, I dot dot. If you remember, the Y, I dot dot is this one's. That means it's this one's. Now, when you square 62, and again you square 91.4, how much do you get? And you divide that by 4, how much do you get? 62 squared plus 91.4 squared. You minus it with 1/8. We've got 153.4 all squared. How much do you get, Vero? Vero, are you out or you're still there? Timekeeper is break. No, it's break. Okay. Is it break? Yeah, you can say something. I cannot see you.
Yeah, but we can.
Yeah. Let's only 2 minutes. Then we finish ANOVA, and we'll take a break. Let's finish ANOVA. Here you said it's 269.12. Now let's do the SS model, where the SS model is 1/r, the sum of T, the sum of B, the I, the J dot squared, 1/TBR, Y dot. Now, let me explain this one. This one is a total of this, is this one. Do you see the Y11 dot? This is the total of the block, of this block. The Y dot, sorry, the Y11 dot, that is the total. That is what we are looking for. That means in order to find it, you must find the total of what? Of these numbers. 1, 2, 3. Must find the total of those numbers. When you come to our example, that means you must find the total in here. Let me do this. Then is 7.6 and 8.8. I'm just giving you example for the first one. What will be the answer here, ladies and gentlemen? The total for the first block. Huh? This is 7.6. Oh yeah. 6.4. What will be the total in here? 45.6. Then what will be the total here? What will be the total here? In here?
37.1.
37.1. And the last one will be how much?
54.3.
Or 54.3. Yes. Now, after getting that, can you find the SS model? Can you find this? Where this is 1/2, then these are those totals. You minus it with 8153 point point, you know the answer. Squared. Why am I forgetting squared? Then the answer, I was told, that is 39,395.165. Now, after finding this, then we find the interaction of treatment and block. This is filter times block or block. Let me say block. People will say, why do you start with B? And this is block. Block times filter. This is what we call the interaction. The interaction. Now the interaction is SS model minus SS filter minus SS operator. Then you must let me know where is Murunga? Am I fast? Rungui? Am I fast? Okay. Then give me the answer, Murunga. What will be the interaction? The answer for the interaction? Muru model minus SS filter minus SS operate. What is the answer, ladies and gentlemen? $18, I was told. Now the last one is SS error, where this is SS total minus SS model. Yes, thank you, Murunga. What will be SSE? SSE is the same as SS total minus SS model. What will be the answer?
20.6.
5. Then we are done doing the ANOVA under the sum of squares. Then you can continue and finish the ANOVA. Then when we are going to come back at 12 past 12, let's come back at 12. Then we start testing the interaction. Thank you very much. Any question for those who are remaining behind?
Yes.
Sir,
Yes.
my concern is on SS total, and they don't the number after comma affect, because this 415.815, I don't know how did they get it, because if I try to punch here, it doesn't not make sense.
You know, that means you have to substitute each and every value to get that. That means you have to say 7.888.
I did that, say, if I do that, it does not listen, say.
Yes.
If I do that, the overall here, okay, unlike before, is 3357.26. If I subtract with that 1 over 8, then I say 153.42 square. I don't get 415.815. What I get is something like 415.04 something.
Okay,
Maybe you can try with your calculator. Try with the calculator, say it does not make sense.
Yeah, no, I'm doing it right now.
Yeah.
Let me just press and see how much do we get. Let me see those values. Okay, let me minimize this. Let me go to, okay, squared. Okay, then minus. Okay, minus into. On the first one, do you get 3357.26? Smanga? Is it Smanga? Blessing. Is it
Yes,
you?
sir. Yes,
Do
sir.
you get on the sum of those three? Do you get
Ye-
335,726?
Yes, sir.
Okay. Then if we agree with, let me go to the next one. The y dot dot, do you get 153.4?
It's 153.42 or 0.4.
153.4.
Not 0.42, ne?
Yeah, not 0.42. Is 62 plus 91.4. It gives you 153.4.
Oh, 0.4. Okay, I see.
Okay. No, thank you very much. Let me take a break. Then
Oh,
we'll come
thank
back.
you.
Thank you.
Sir,
Ladies and gentlemen, welcome back. Welcome back. Now let's complete the ANOVA table. Here we are having the source of variation. We are having the filter, operator, filter by operator, or we call it the interaction. Then here we are having the error. Here we are having, we are having the total. Here we are having the degrees of freedom. Here we are having the sum of squares, the mean sum of squares, and the F ratio. Now, since we got these numbers, the SS total was 415.815. The filter was 108.045. The block was 269.12. The interaction was 18. The error was 20.65. Ladies and gentlemen, what is the degrees of freedom for filter? What will be the degrees of freedom for filter? It will be 1. Operator, 1. Interaction,
1.
1. Error,
4.
4. Total,
7.
7. Now, I hope you understand how we got these values. These values. If you look at,
Hello, sir. Oh,
yes,
never mind.
yes.
It's fine. It's fine. I wanted to ask for the degrees of freedom, like the formula.
Oh, yeah. I'm here. Now, this is the degrees of freedom. This is the degrees of freedom, which is TRB minus 1. This is for what? For total. Now, you go to the next one, which is the SS error. This is the one. The TB R minus 1. Then you go to, what is happening now? Let me do this. Okay. Let me do this. Now, this is the total. This is the treatment, the degrees of freedom for the treatment. This is the degrees of freedom for blocks. Do you see? Then this is the interaction, the degrees of freedom for the interaction. Do you see it, ladies and gentlemen? Now, give me the answer for MS for the filter. Let me do this and this. Filter, this is just the same. If you divide 1 by that, then you get that. Then how much is this one? 20.65 divided by 4. The error, 5.1625. Am I fast, ladies and gentlemen? Am I fast? You must let me know. Murongwa, yes. Then what will be the F ratio for this? The F ratio will be, for the first one is 20.927, okay, or 0.93, that's fine. What will be for the operator? 52.13. We can say here, let's remove 7 and put 3 here. Then what will be for the interaction? Okay, somebody has given me the answer. The interaction, yes. Okay, thank you very much. Thank you very, very much. Now, after doing this, the ANOVA table, we have done this, we have constructed this, we want to test for the interaction. Now, this is how we test for the interaction. Testing for the interaction, we have to test whether or not all the interactions is equals to 0. At least one interaction is not equals to 0. What do we mean? We mean here there was no need for interaction. Interaction is not important, but at least here there is one that is important. Now we have to test it. This is the test statistic, and we know the value from the table, the critical value. How to find the critical value? How to find the critical value? Let me do this. Let me close this. Okay, I cannot close that. Okay. Then now we have to find the critical value. What will be the critical value? Now let's start there. We are saying H naught. We want to test for the interaction. It's equals to 0. At least one different, or we say this is not equals to 0. Now your alpha is 0.05. The test statistic. Now your F, how much will be your test statistic for interaction? Test statistic for interaction. Test statistic, not a critical value. Test statistic is 3.49, as you told me. What will be the critical value? The critical value will be 1 and 4 of 0.05. Now we got 7.71. Now, what we have is this. Is 1 and 4. 1 and 4. That means it's going to be 7.71. Do you all see it, ladies and gentlemen? Do you all see it? Okay. then what are you going to say? What will be your conclusion? What will be your conclusion? We fail to reject. Do you agree with Neo?
Yes, sir.
Oh, yes. Then, okay, let's do this. Then if you fail to reject, now, this is the statement. If we fail to reject the null hypothesis about the interaction, we test the main effects. But if we fail to, if we reject the null hypothesis, there is no need to test the treatment and the blocks. Now, since we failed to reject, now we need to test the treatment and the blocks under the fixed model, and also the variance under the what? The random effects. Do you understand, ladies and gentlemen? We only do, let me do this. We only do, this follows that we only do the test for the mean effects only if the test about the interaction effects conclude that the interaction effects are not present. That is when is H naught. H naught means there is no, the interactions effects are not present. There's no interaction there. Now, let me explain it again. You test for the interaction. And if you fail to reject the interaction, then we test the main effects. Remember, the main effects are the mean of the treatment, the mean of the block, the variance. And the mean, if you want to test for the mean and the mean of the treatment and the blocks, you have to use the fixed effect model. If you want to test for the variance, you have to use what we call a random effects. Now, you understand, isn't it? I hope I've explained it. For conclusion, we fail to reject the null hypothesis at alpha is equals to 0.05, isn't it? And conclude that, isn't it? We conclude that the interaction effects are not present. There is no interaction. Do you understand, Siva? Karabu? Where is? Yeah, you can talk. I'm listening.
Sir,
Somebody's reading.
so
Yes.
Yes.
if the interaction effects are present, what does it mean the blocking was efficient?
100%. Yes. Remember, interaction means the block and also the treatment, isn't it? Is a joint thing, is an interaction. They interact somewhere. The graph which I managed to show you, if it's here, this one. Do you see? If interactions is present, look at the blocks. They interact with one another. Even the treatment which are here, the A, the B, the C. Do you see how the graph interact with each other? But where there is no interaction, look at the graphs, they don't even touch each other. Yes, sir. Okay, which means if we were to reject, we were going to say there is an interaction. Yes, there is this. Do you see where it says interaction is present, that means this is how it looks like. This is how it looks like whenever the interaction is present. This thing, they mingle with each other. Now, I hope I've explained that, because I want us to do the main effects, because it says if we fail to reject the interaction, then we must do the main effect. Why are we doing the main effect? We want to check whether the mean of the treatment are the same. Also, we want to check whether the blocks is effective. Whether the blocks is effective. That is what we want to check. Yes. Somebody saying something?
So do we wait to check for all of them before we can conclude this thing, or maybe we can just see if we can see that we are failing to reject for one, we can just conclude that there's no interaction.
No, you have to test for interaction first. That is what you have to do. Check whether there is an interaction. And if there is interaction, then that means you are done. Why then should you continue testing the mean and the blocks, but the treatment and also the blocks? But if there is no interaction, we want to check. We might get that those things are fine, but it's only the interaction. Blessing, do you understand?
Yes, I understand.
Let's go to the statement. Now, the statement says, if we fail to reject the null hypothesis about the interaction, which we did, we test the main effects, which are treatment or block effects, under both models, which we did, the fixed and the random effects model. Isn't it? The test about the main effects are meaningful only if there are no block by treatment effects. That means if we have failed to reject. That is what it says. This follows that we only do the test for the main effects only if the test of the interaction concludes that the interaction are not present, and that is what we did. Now it means, let's come to the comparison. They are done only if ANOVA tests conclude that block by treatment effects are absent. That means why? We know very well that whenever they are absent, it means they are not present. Obvious. If something is absent, that means no present. It's the same thing as failing to reject the H naught. Do you understand, ladies and gentlemen? Okay. I don't see, but let me do this, minimize this. Yes, then that some treatment means are different. And we also do it whenever the comparison, whenever we get the means to be what? Different. And remember, the means are different under H1. That means we must, this comparison will be done whenever the means are what? Are different. Now we have to do this, the main effect. We have to check the mean, the treatment, and also the blocks under the fixed. And we have to check the variance. But the comparison, we are doing it using the treatment. The treatment. And whenever the means of the treatment is what? Rejected. Now let's go back. Now what do we do? What we do is this. It's this one. Now what we do is this one. What we do is this one and also this one. And we do the comparison. Only if what? The treatment, this treatment, the H0 is what? Rejected. When the H0 is what? Rejected. Now let's continue. Do you understand, ladies and gentlemen, what we are going to do? Oh, yes. Now we do what we call fixed effect. Now we have to, there are two things under fixed. We have to check the mean of the treatment and the mean of blocks. Now, H0, it says the means or the treatment, the mean of the treatments are the same. The other one says at least one, or let's say this is not equals to 0. Similarly, with blocks. Similarly, with blocks. It's not equals to B2. Or the Bj is not equals to 0. Now, we have to test. Now, this is F is equals to MST, where this T is filter, divided by MSE. What is the answer, ladies and gentlemen? And what is the answer for test statistic here? Ladies and gentlemen, ladies and gentlemen, are you still there? $20.93. Then what about the for okay 52.13? Do you agree with them? Do you agree with them? Dineo, yes. Okay. Now, what do you think? What will be the critical value for the treatment and the critical value for the block? $7.71. 7.71. Now, what can you say, ladies and gentlemen? What can you say? We reject, yes, we reject here. And we reject. We reject, and we are saying what? The means are different, isn't it? The means are what? Are different. The means of the filters are different. Do you all see it? That we are going to. Do you all see it that we are going to reject? Okay. Now, since we rejected, since we concluded, the question is, can we do the pairwise? pairwise comparison. And why? Why do we, you are saying yes. Why are we doing the pairwise comparison? Because we rejected H naught. Okay, because they are both, isn't it? There is block and because when you are saying we rejected H naught, which H naught are you talking about? Because the sum of the treatment means are not the same. Okay, that's why we are doing the because the means are different. We to see which treatment differ. Okay, means. Okay, now let's do this. Listen to this. The pairwise comparison, we are doing it if the ANOVA test under the fixed effect model concludes that the sum treatment means are different. And that is what you are saying. We are doing the comparison because the treatment means are different. It means we rejected the H naught. Do you all agree? Okay. Tabizo. Manya. I don't hear
Yes,
you.
sir.
Oh, yes. Oh, you are still here.
I'm still here. Sir.
Yes. Then, now, what we have to do now is to do the comparison. Okay, wait a bit. So we don't consider the blocks in order to do. Yes. They said we only do the comparison, the pairwise comparison using the treatment. We only use the treatment. That means since, okay, I want to ask you something. Now, look at blocks. What can you say about blocks? What will be the conclusion about blocks? Because we did the treatment. What can you say about blocks? What can you say about blocks? Okay, they're saying blocks effective. Somebody, Ezekiel, you are saying we fail to reject. Do you agree with Ezekiel? Do we reject or fail to reject the blocks? Under blocks?
No, say we reject.
Okay, we reject. Blessing. And conclude what? And conclude what? And conclude what? Blessing. Yeah, that the blocks are effective. Yes. We conclude that the blocking was effective. We conclude that blocking was effective. That means we can say we conclude that operator was effective as a block. Yes. Do you see it, ladies and gentlemen? Do you see it, ladies and gentlemen?
Yeah, so, can you also show us for the other one for some of us to be sure about the conclusion, because it's I'm by the Sanyana, but now I understand.
Which one? This
The
one.
The one, yeah. Oh, okay, yeah. I see, okay.
Okay. Then, Blessing, what comes next is for you to do the comparison test. No, the comparison. You must do this. The random effects. Yeah, no, you must remind me immediately after class, because yesterday I forgot to put the slides. I am very sorry.
So do we have another class today?
Yeah, it's a tutorial. It's not a class. It's a tutorial where
Can
I'm not
we
going to talk like as I do now.
Okay, can we continue on this part, that tutorial, because it's we are tired, and some of us we can't focus when we are tired.
Isn't it you're going to eat? You are having 1 hour, 2 hours to eat and rest for an hour. You can eat and rest for an hour. Then you'll come
Yes,
back.
like I was saying, Guru, for us to continue on this part, some of us we need to digest Nyana before we can add the rest.
Oh, you mean random effects?
Yes.
Yeah, I'm giving you as a homework to do.
No, okay.
Yes, yes. Now, what we do right now is just to do this. We are at the end. People, we are just at the end. Now we do the comparison. Can we check whether the means are declared significantly different or not? Can we do it? Can we do this one? The LSD. The LSD. Now, let's, yes, you can say something. I'm listening. Is it possible that the number of replication within individual blocks may differ? No, I don't think they can differ, unless if they differ, you have to estimate the other one, but they don't differ. They will be the same, because even if you enter that on Excel, it says how many replication. That means you must specify that which block, each and every block. Yes, yes, they won't differ. Now, LSD is equals to alpha over 2 of what is that? Of 4, I think it is 4 for the 2 times 2. Yes, is it 2 times 2? Let me go back a little bit. Oh, okay, we are here. Yes, 2 times 2. Yes, 2 times 2. Alpha over 2, which is 2 MSE over BT or BR. Yes, then it will be the means. What is the answer here? Now, what will be the T for 0.025? The square root of 2. This one you will insert it. Is there up there? What is the answer? The LSD. Vero. Is that LSD? Okay, 3.288. Do you agree with Vero? Do you agree with Vero? Yes or no? Do you agree with Vero? Ladies and gentlemen, do you agree with Vero? Where are people? People, are you still there?
Yes, correct, sir.
Yeah, I'm Karela, but this
Hey.
one is the last one. We agree with Vero. Blessing, do you agree with Vero? What's the value for T? Okay, let's go back. Let's do this. Is 0.25 and 4. It will be 2.776. 2.776. Dineo, you are getting yes, that is your value for the table. Me too. No, okay. T4 0.025 is 2.776. Then what will be the LSD? What will be the LSD? They said it's 4.46. Okay. Somebody's getting 1.6 dinero. Oh, okay. Then what is R? R is replication. How many things are repeated? 2. Okay, they've answered you. Leslie, are you winning? Lesma Ada, are you winning? Lesma Ada. Oh yeah, thank you very much. Now, let's test the treatment. Now, the mean of 1 dot minus the mean of 2 dot. The question, is it greater than the LSD? This is the question. What is the mean? What is the values for the mean of treatment 1? The mean of treatment 1? The mean for treatment 1, you're saying is 31. Do you agree with Karabo and minus what will be the mean for the treatment 2? The mean for treatment 2? Mean for treatment 2 is how much? 45.7. Ladies and gentlemen, the mean, this mean. Do you see this mean? This is the mean here. Now, this is the mean here. This mean. And here you are having how many numbers? This is 2 and also 2. That means here you are having how many? You are having 4, isn't it? N is equals to 4. Why do you divide by 2? Ladies and gentlemen, yeah, no, you are tired. No, the number, the observations. The mean is observations, not the treatment, it's observations. When you divide, the mean is observations, not treatment. The mean is observations. You know very well. You know very well. You know very, very well. This is 15.5 and 22.85. They said the answer is 7.35. Why 31? Yes, that is what I was asking them. Why do they have 31? Because it means they've divided by 2 and you are having 4 observations, but you divide by 2. It does not make sense. It doesn't make sense unless otherwise you find the mean, the means, the mean from block 1 and the mean from block 2, then you divide by 2. Then that can make sense, but we don't do that. The formula. Then what can you say about 7.35 and 4.46. Is this one greater than the LSD? Then if it's yes, what is the conclusion? What is the conclusion? This is just the last one. What is the conclusion? The mean 1 and 2 are declared significantly different. That means mean 1, yes, significantly different. I'm very sorry for today. We have this example took time, but it was for your own benefit, for your own course. Make sure that when you arrive home today, you practice it. In the tutorial, we won't do this in a tutorial. I will reserve it for next week. That means number 1 and number 2, we are not going to do it. We'll do number 3 and number 4 in the tutorials. Any question, ladies and gentlemen, as I'm going to give you announcements? Any question? Any question? The first announcement is that immediately, Stephen, do you know me very well, or you just hear my voice? I'm short than Tatamalule. I'm very short than Tatamalule. Collection of scripts immediately after this class. Collect your scripts at Mr. Maloga's office. Tutorial questions, they are there. We are going to do number 3 and number 4 at 3 o'clock. The third announcement is that tomorrow they will give you a feedback about the test, and also those who do not write the test, they will tell you about the special test. The last one is that next week, Friday, there will be a quiz. 7:30 next week, Friday, there will be a quiz. Any question on announcements? Any question on announcements? If there are no questions,
What's the cutoff time?
Sir?
What's the cutoff time for fetching the scripts?
I don't know. I don't know. But personally, at around 3, there will be a class. That means I'm expecting everyone to be in class at 3. That means the cut point will be 3.
Okay, thank you.
Yes, thank you very much. See you at 3 o'clock.